Good evening. Good evening, sir. Okay, guys, good evening again. Are we all here now, or we're waiting for a few? Which is it? Um, Oliver, I need to talk to you.
Not sure. Is nine somebody in the class?
I'm not sure. You must tell me.
Maybe say more than nine. I sent a message in a WhatsApp group to other people.
Okay. Oliver sent a message just now, please. Can I check? All right. Okay. Sam, I soon respond to you. I saw your message. I soon respond to you. Cool. Oliver, are you hearing me?
Yes, I'm hearing you.
Man, I sent you a message, a private message a while ago. Can you call me now, please? All right, give me a minute, guys. I'm gonna take a call from Oliver. Okay, guys. So welcome to what I will call day one. There are some housekeeping matters that I need to attend to. Normally, what I do, I give you a little leeway to come into class. Let's hope it's not going to affect us, because I know some of you finish work at 5 o'clock. So I normally give you a little period. For those of you who are coming, who are joining me for the first time, maybe wondering why um, you didn't see me earlier, I will normally give you a little bit of time to come in, because I'm cognizant that you finish working at 5, some of you, or most of you. But there were some other little matters that I needed to deal with that I don't want to deal with over the recording. So I'm speaking to some students in particular. I just had my second chat. Um, and there is one other student that I need to speak to. All right, with that said, let us see if I can start sharing to just bring up some stuff. I'm going to be muting. Give me a minute, please. All right, students, let's go. I hope and trust that you have had a good day and that you're doing pretty well. Let's begin. So we're
Yes,
looking at limits and theorems. That's Unit 1, limits and theorems. So we're going to be looking at the intuitive approach. We're looking at the intuitive approach to evaluating our limits. The intuitive approach is one where will be carried forward into evaluating piecewise functions, and it really is a basis of understanding limits of a function. After we would have set the foundation for the intuitive approach, then I'm going to be moving to the calculations method, which is a much easier method in evaluating the limits of functions, but the intuitive approach has its advantages. One of the advantages of the intuitive approach is evaluation of our piecewise functions. Very important concept. Piecewise is one of those must-haves, as I told you, one of those must-haves that will come for anywhere between 10 and 15 marks out of a 30-mark question. So when you see a question on piecewise, it's something that you should be running towards. So,
yes, sir.
so it says that we're going to be looking at to evaluate the limit as extends to 1 of x plus 1. We're looking at the limit as x tends to 1 of x plus 1. I'm trying to develop in all of you is the whole business of approaching 1. X is tending or approaching 1. The concept is, for the intuitive approach, x is not really 1. X is tending to 1. X is getting as close as possible to 1, but x is just not 1. X will never be 1 for that matter. So we are trying our utmost best to get x to a number very, 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 very close to 1. We're not sure if we're going to succeed in that. Can you give me a number that you think is close enough?
0.8. 0.8.
See that you think you could all right. Okay, so I use 2 devices. I use multiple devices when I'm teaching, guys. For those of you who are just coming on, my sharing device is different from my speaking device, and and the speaking device just reconnected. So I went out just now. What I was asking you just now is
Yeah, you did a breakup earlier.
right. Am I coming across much clearer now?
Yes, a lot clearer.
Okay, maybe that's why it reconnected. So I'm going to be investigating my limit from both the left-hand side and the right-hand side. I want you to think back to a number line. I want you to think back to a number line. And on the left-hand side of the number line, what sets of numbers do I find?
The negative numbers.
The negative ones, right? And therefore, the positive ones are on the right-hand side. But
Yeah.
when I said the left-hand side to what?
The zero.
Very good. So it's the left-hand side to the zero. So I use my zero as my marker, which is my neutral point there. And then to the left of zero is where I'll have my negative numbers. And to the right of zero is where I'll have my positive numbers. Very good. Now, I want you to picture one. Picture one on the number line. I don't need to draw it because you guys are calculus students. So I want you to picture one. To the left of one, I have what again?
0.
0. And therefore, I'm going to have 2 here. All right? All right, good. Now, look at what is happening. I am approaching 1. I'm approaching 1 this way, and I'm approaching 1 this way. So I'm approaching 1 from the left-hand side, and I'm going to also approach 1 from the right-hand side. Now, as I approach 1 from the left-hand side, I want a number. Tell me a number that you think it's close to 1 from the left-hand side. Give me a number that you think is close to 1.
0.8. 0.8.
0.8. And I closer to than 0.8?
0.9.
Whoa. Colin, if that's you speaking, you are breaking up. Can somebody try to speak? Let me see if it's Colin alone, please.
Colin was saying 0.8 and 0.9. So did you hear what he said?
I'm hearing you clearer than Colin. So it's Colin's system that is.
So I think it's your internet because you're breaking up.
So he was saying that what?
I'm saying I think it's your internet
I
because
said, go again, my love, please.
He was saying 0.8 and 0.9.
All right, so I would prefer 0.9 because 0.9 is closer than 0.8. So I'm just checking to see my internet. Okay. It could very well be me. It could very well be me. I have just one bar. All right, let me switch the data. I really have one bar and it's not going to sustain anything. Let me switch the data. Give me a minute. Much clearer, should I ask?
Now we're hearing you clear again.
All right, you hear me clear again. All right, so I just switched the data, so I don't know what is happening to the internet. So let's hope it works. If I'm not coming across clear, just let me know, please, so that I can maybe switch back to Wi-Fi. All right. So I was saying to you, yes, Colin, I hear you. So I would say 0.9 is closer from the left. But I'll ask a question. Am I able to go any closer than 0.9?
Yes, but
0.999.
Hello?
well, yeah, it's sound about right. Wait, that's not work? Hold on. No, that's not one. I'm gonna remember. So she said 0.99. All right.
0.99. So what about the rest of you in class? You know, are you hearing me or is just hearing me? I don't know if it's hearing us, but what about others of you?
All right, so it depends on how many decimal places you want.
No, man, and you tell me, where else can I go from there now?
0.999, sir.
0.999, good. And give me one more. How much closer can I get?
0.49. Not
0.4.
No, not
0.49.
No, nine.
4 9. Sorry.
I know, but he has to be very, very specific with what it is that he's saying. Right? He has to be very specific with what he's saying. So 0.9999. That's what you're saying.
Yes, sir. Never want to twist my tongue.
All right. So 0.9999. All right, good. All right, that's very good. So that is the limit as I move from the left-hand side. That's a left-hand side limit. Now, when I move from the right-hand side, I am trying to close to 1. So I am moving to 2, and I want to get very close to 1. This is where I really want to go. But I can't go right here, so I want to get very close because I want to investigate what is happening as I get closer and closer to that number. So as I get closer to 1 from the right-hand side, what number is a good starting point?
Well, 1.1.
No,
1.1.
Oh,
1.1.
0.01. No, 1.0.
1.0.
1.0 be 1?
1.0 is 1, and I don't want 1.
1.1. 1.1.
All right, go back previous answer.
1.1. All right. Because 1.0 is really 1, and I don't want 1. So I'm going to go to 1.1. No, I want to get closer to 1 than 1.1. What do you think I'm going to use?
1.01.
1.01 would be correct. 1.01. And get closer, get what?
1.02.
All right, I hear Adrian said 1.02. But
yeah,
is 1.02 a bigger number than 1.01, Adrian?
Yes, sir.
Yes, I wouldn't want to go 1.0. I wouldn't want to go 1.02 because I want a smaller number.
All right, so you go 1.1. No, that's what I'm bigger.
Yeah,
1.001.
1.001. Thanks, AC. So, Adrian, you tell me now that you see the pattern, based on what Asin just answered a while ago, what you think the last one would be in this case? Look at the pattern that we have on the board here. 1.0, 1.01, 1.001. What do you think the other one is going to be? Adrian, are you meant to talk to you?
Oh, sorry about that, sir. Sorry about that. 1.0001.
Very good, son. 1.0001. Very nice. All right. So that's what it is. That's what it is. And then we're going to evaluate. Oopsie daisy. Then we're going to evaluate. Okay. Don't want to. So that's just so that's exactly what it is that we're going to do, right? Then anywhere in the original function, anywhere in the original function I have, I'm going to substitute these values. All of those values I'm going to substitute. Anywhere in the original function, I'm going to substitute those values. And when I substitute anywhere in the function I see x, I'm going to substitute 0.9. So 0.9 plus 1 gives me my 1.9. And then 0.99 plus 1 will give me my 1.99. Can you see that?
Hold on this second, please. Say that over again.
What I'm saying to you, anywhere in the function I see this x, I'm going to substitute these values, all of these values here. 1, 2, 3, 4.
Okay.
So 0.9 plus 1 is 1.9. You see that? Colin?
Yes, sir. And 0.99 plus
Plus
1
1
is
equals?
1.99.
Very good. And 0.999 plus 1 gives me my 1.999. Can you agree with this side over here now?
Yeah, yes, sir.
All right. So what about Shamari? Are you understanding what it is that we're talking about?
Which side?
Can you hear me?
We suspected something.
I can
Well,
hear
I've seen
you
it
now.
myself,
Yeah.
this.
What?
Okay.
Poison.
Yes, sir, I can understand it. I watched a video today.
No, it's
I passed the card.
You watch a video,
Shoot.
or you watch a video from one of the past recordings?
Yes, sir.
And then
Yeah, man. But in class tonight, the more want you to answer me because I need to be able to differentiate. It's like I can differentiate those other voices. I taught Colin in the associate degree program, so I know his voice. And I teach the others, in some other different courses. So I really need to get the voices. So like you and Amanda, especially the new ones coming up, all of you I want to hear from, But when I
Okay,
ask, I
sir.
want you guys to participate with what is happening. So yeah, man, you want to answer, make them know. So you look on the recording, and this is the way to go, guys. And this is why one of the reasons I have side here. All right. So yeah, man, talk. I don't want to proceed over the future. All right, because I feel like I'm struggling, but I feel a little better now. Know that you're saying that you're following. All right, good. So from the right hand side, I'm going to be doing the same thing. I'm going to be doing the same thing on the right hand side. Right hand side, anywhere in the function I see x, I'm going to substitute my 1.1. So 1.1
Sir, if you're speaking, we're not hearing you. Sir did say something like he's coming or something of that sort a while ago.
No, I'm just really struggling tonight with my internet. I don't know what is happening. The sharing device is okay, but the speaking device is just connecting and reconnecting and just keep reconnecting. I apologize. Um,
The speaking device, a phone. A phone. Maybe for a restart. Okay.
Like.
Probably microphone.
am I back up now?
Yes, sir.
I really don't know what is happening. Is anybody else having an issue with their internet?
No, not at the moment. On the phone.
Not really, sir, no.
I always have issue with my internet, so I can't be any judge of this.
We all know this, Oliver. Oh my goodness, I don't know what is happening. Ay, ay, ay. Should I switch back to Wi-Fi? Let me see if I should. Wi-Fi has only one bar. All right, let's see if we can get 45 minutes out of this. All right. So what I was saying to you is when I investigate what is happening from the left-hand side, when I evaluate all of those, as I get closer and closer and closer to 1 from the left-hand side, the limit is approaching 2. As I get closer and closer and closer from the right-hand side, the limit is approaching 2. So you may ask, sir, is only 4 numbers you're supposed to put in? No, not necessarily. I only stop at 4 for ease of convenience. I could go up to 0.99999, and I could go up to 1.00001. And I can do that as far as I could possibly go. And then, of course, I'm going to get here my answer to be 1.9999 and another 9. And here's going to be 2.000, one more 0, and then a 1. So as I go down and get increasingly closer, as I go down, I get closer. I get closer to 1. And I go down, I get closer to 1. What I'm saying to you is when I get closer to 1, my limit is on both sides approaching 2. So therefore, since the limit is approaching 2 from both sides, I can conclude that the limit is of a good behavior, since the left-hand side of the limit is equal to the right-hand side of the limit. The limit exists, and the limit is going to be 2. I want you to think about something, especially for those of you who are attempting this course for the very first time. I want you to picture this. Understandably, also that most of you are adults and as such live on your own. But think back to when you were living with your parents, or you may have children of your own and encounter this scenario that I'm going to create. So a child decides that he wants to go to a birthday party. In the child's mind, me not ask mommy, I will ask because everything mommy
Sir, your audio gone.
is when it says yes.
Sir, you're
Oh
breaking up.
Lord, this is not working out. Are you guys hearing me better now?
Yes, sir.
All right. I really apologize. I really don't know what is happening. Never normally have this issue.
So
Normally,
technology stay sometime.
yeah, but why me tonight? I mean, normally if there's an issue, I switch from one internet access to the other, and the other one will work seamlessly. But the Wi-Fi has.
Maybe your device just needs to restart or something.
Oh no, but that will take up too much time. All right. If it goes again, I'll just restart the device. If it goes again, but please and thanks. So just listen out. If you're not hearing me, just say to me, sir, I'm not hearing you. And then I'll just pause again and then just restart the device, and then I'll see what will happen. I don't want to use my cell phone because it goes off very quickly and very often, and I don't want to disturb the class. So that's why I'm using another speaking device. All right, let's go again. So what I was saying to you is, so this child now don't want to go to mommy because mommy is when they say no. So her option is, or his option would be to go to daddy to ask daddy, may I be allowed to go to this party? And then now the child decides in his or her mind, me not ask mommy. Then mommy sees the child getting ready and says, where are you going? Oh, daddy said that I could go to the party. Nope, you're not going nowhere. Take off back your clothes and go sit down. Will that child be able to leave the house? Yes or no?
Good question.
Well,
Happy wife, happy life. So no.
Very good answer. But also, if the child wants to live, the child will take off back the clothes because mommy will knock out child, right? So right. So you know that the child will not be able to go to the party. On the other hand, if the child asks daddy and daddy says yes, and then mommy also says yes, you know that is a yes across the board. So that is going to happen and the child will be able to go to the party. That's exactly what is happening with the limits. So if one is saying something different from the other, the limit does not exist. The child can't go to the party. But if both limits from the left-hand side and the right-hand side are singing to the same tune, you're good to go. The limit exists. The function tends to that limit. The limit is of a good behavior. You're good to go. So just remember, you have to check the limit from both sides of the digit to see how the limit is behaving. Is the limit behaving in a similar fashion? Once the answer is yes, then the limit exists. Then you can go ahead and see that the limit is tending to whatever number the limit is tending to, right? Also be very careful that not all questions you're going to be moving from 0.9 to 0.99. It depends on where you are at on the number line. If I'm at 1, for sure, it's going to be 0.9 and 0.99, so forth and so on, and then 1.1 and that. But if I'm at a different number on the number line, it's not going to be moving from the same thing. So you have to be very vigilant and to see what is happening. All right?
Yeah.
So
question.
we say that it's of. Go ahead.
So x plus 1 is because 1 inside of the bracket, we have to try and move closer to it specifically.
No,
No?
we're trying to get closer to it because this x tending to 1 down the bottom here. So
okay, so this is a part of the equation too. Is it?
right. No, the function is x plus 1. The function is x plus 1. But the condition to the function is how that is read. Look at what is here. This is read. Evaluate the limit as x tends or approach
Okay.
function x plus 1. So it is approaching this one down the bottom. So
Yeah, they're gone.
that subscript have one on limit. You know what to do with it. Because you find limits, whatever in there is going to tell you what to do with the limit. Whatever is down there will tell you what to do with the limit. And then that limit now is going to be affecting the function. The function now is what you're going to be substituting in order to evaluate, to observe the behavior function. So it's really the function that you're working with, But you have so put it this. You go with $20,000 in your pocket. Can you spend more than 20,000?
No.
Okay, medium. Right. You can't spend more. So your limit is $1,000. But you don't know what it is that you're going to spend. So you really don't know yet. Because you don't know what it is that you're going to pick up. Because some people go to the supermarket with a list. Others just go around with an idea what they want in their headspace. And then they will also look and say, oh, thank you, I needed this. All right? No. There is no way you can spend more than $20,000. So if when you reach to the cashier, she says 20,500, you best believe that you have to go take off 500 off it because your budget, your limit was $20,000. All right? So that limit at the bottom there, extending to 1, is telling me what is happening. So I can either spend more or I can't spend more, but I can spend less. All right? So that's a concept of a limit. Limit tells me that I cannot go above. I can huddle beneath, but I can't go above. Fair enough?
Yes, sir.
What about the rest of you in the class? Do you understand?
Yes, sir.
All right.
Yes,
Good,
sir.
thanks. All right. Ouch. Now, let us look at another example. So you see what is happening here now with that example? I have changed my limit. This time now the limit is tending to 2.
Hello? Is that still a talk? Anybody else are here?
Some variable inside here. Could
Yeah, you're
contain
breaking
one
up
variable or
Sir, we can't hear you.
oh God, let me Lord help me.
Sir, your internet don't like you this evening at all.
And Astenia, when I like how you laugh at me now, you know.
The moment
Oh.
you start talking the irrelevant things, you're fine. When you start talking the important things, you're nowhere to be found.
Mm,
You're not getting no justice this evening, mister.
not a justice at all. Jeez and peas. No man. And you want to see when I have the speaking device right up in my face. If it get any closer, I'm gonna swallow it.
You try restarting the phone, sir?
All right. Let me do that in 2 seconds. All right. I'm gonna do that now.
Hmm.
I'm gonna do it now. Thanks. Oh, sweet Lamb of God. Restart. All right, guys.
There's a feedback.
Are you hearing me, guys?
Yes, sir.
All right. So a message came up on the.
This meeting is being recorded.
Oh, Jesus. Help me. All right. Are you hearing me now?
Yes, sir.
All right. So a message came up to say that I'm supposed to join the meeting via the web. So I had to switch devices, and all this is gone. I don't know what is happening today. I don't them it never normally like this. Let me know if you're seeing the screen, please.
Yes, sir. We're seeing
Yes,
this.
sir.
All right, good,
Yes.
thanks. All right. So tell me now, from the left-hand side here, I'm moving from 2. My number line this time, my base point is 2. To the right of 2, I'm going to have 3. To the left of 2, I'm going to have 1. Remember now, the limits here says as x tends to 2. As I go in here from the left, as I go in here from the right, give me a number closest to 2 from the left.
1.9.
1.9, Colin, is a good number to start with. Give me another number closer.
1.99.
Sounds good. Give me 2 more.
1.999.
And then 1.9999. And I can go on and on. Very nice. Love the sound of that. You guys are understanding. After this, I'm going to jump into the calculations approach, so it is that you can see a little clearer what is really happening. The right-hand side, I'm moving from the right, moving from 3, trying to get closer to. What do I write? What's my first?
Repeat that, sir.
What's my starting point? Go
So
again.
you're approaching from 3 to 2, right?
No, man, I'm going to 2 now. Right, from 3 to 2.
Go
Yeah,
to 2 from 3.
Right.
2.1.
2.1 is correct. Thank you, sir. Then
2.01.
sounds like a good plan. Then
2.001.
sounds nice. And then, of course, I'll do the last one to get 2.0001. All right, do me a favor. This exercise now is just a test to see if you guys actually know how to use your calculator. So I'm going to give you 2 minutes. I'm going to give you a minute for you to plug those. Okay, it's a rational function. We give you 2 minutes, a minute each. You're going to plug those numbers into the rational function for me and evaluate each of those points from the left and each of those points from the right and tell me what it is that you'll get. Quick and fast. No, I gave an exercise, Astine. What is being projected now on screen? I want you to evaluate for me using your calculators. It's just me checking to know that you guys know how to use the calculators. Use a calculator to evaluate each point under the left hand side and each point under the right hand side.
Well, I guess I don't know if you use my calculator, but give me a fraction.
No problem. That's fine. That's fine.
So there should be something on your calculator that converts it back to a decimal.
That's right.
Don't let sir ask you what calculator you're using.
Colin,
Yes.
name the brand of the calculator, please.
There should be,
Is a joyous.
Colleen, Colleen, there should be a B/C on your device.
That's if it comes with it. Colin, what brand are you using, Colin? What's the name of the calculator?
Yeah, ABS. No, about it.
Like an iPhone.
It's usually the button that's below the x to the power of -1. You get a fraction, you press that and it converts it back to a decimal. Okay?
Colin? Colin?
Yeah, yes, sir.
Save yourself from the trouble. What calculator are you using, son?
Casco.
A who?
Casco.
A Casco? What's that?
Casio, sorry. Casio.
Oh, the Casio. Oh, anybody else using a Joyous?
Sir, get away.
Right? The Joyous calculators are not good. If you have one, drop it in the bin, get you a Casio.
First of all, it's a join us. Thank you.
Join us, Joyous. Same difference. Who are they? All right. Okay, yes, Colin. So asking was correct. So look to see if you see S, D, or F to D, and that should give you something to play around
S,
with.
SD or
S,
F to
S, F to D or S to D, whichever one. Yes? No? Are
no,
we still don't find it?
still don't find it.
Hmm.
We can't care about the calculator.
Well, which level is it? Is it the 82 or the 115?
82 ES plus.
Is 82 ES plus?
Yeah.
No man, that's not a bad brand. It's there, man. Look in the middle, just before, just above the 8, the 7, 8, 9 key, either closer to the 7 or the 9. You may say F as in Frank to D as in dog, or S as in Shan to D as in Douglas. So F to D or S to D.
Okay, I see it. Literally S. Okay, I see it. Okay, I see it. Okay, I find it. I find it, sir.
Good. Good. Shamari, are you finished?
I don't really have a calculator, you know, sir, but I had done this. I had done it from I was watching the video earlier.
Okay, good job. I'm very happy. I'm proud of you. I cannot be even more prouder. Very nice. So that means you're fully following what is happening, right?
Correct, sir.
Very nice. So it means then that if you fail the course, we should have you. Well, let me not say fail. If you get a B plus for the course, you should do it over.
Quite possibly, sir.
All right. All right. Okay. So let's go back to the document now, because time is against us. So that's what I got. Colin, what say you?
Come on, I do something wrong. I don't even remotely close.
All right. So that's why I specifically asked to use the calculators, because your calculators are going to be your best friend for calculus 1. And if you think that's going to be our best friend, check calculus 2, you're going to have it even closer. So you need to be able to use the calculator to evaluate some of these things. Is there anybody else in the class having a difficulty with the calculator, or you all get to the same value as I have projected here? Or is just Colin alone? The rest of you talk to me. I hear from Shamar already. I think
No good.
you're
Yes,
good.
sir.
Yes,
And
sir.
right. What about oh, she's not. Oh, she left. Okay. There was a student. Oh, she left. Simon, how you say, Papa? You good?
Yes, sir.
All right, good job. Oh, come on. Don't want it to drop. To give me any problems. All right. So that's what it is. That's what it is. Right? So we say that this is of a good behavior again, because if you look at it, 1.9 is all the way up to 3.2. Right? Because that is really not close to 2. But we went a little closer to 2 using 1.99. And then the limit came out to be 3.02. Yet closer, 3.002. And we got even closer using 1.9999. Now, if I had used 9999 and another 9, I would have gotten 3.00002, which is even still closer. Now, 2.1 gave me 2.81. That's kind of not close at all to the limit 3. But when I went up to 2.01, I got 2.98. Still not so close. I think I can get closer. When I went further, I got 2.998001. Wow, that's close. Let me see if I can get closer. Yes, 2.9998,000. All right. So, in a nutshell, that's exactly what it is. Now, for the last couple of minutes of the session, what I want to show you here, and let me go back. Let me go back to where I started here. And what I'm going to do is I'm going to look at I'm going to write the question again. I'm going to say the limit as, sorry, the point was just way too big right here.
Oh, sir. You're supposed to divide. Oh.
Okay. Yes, you're supposed to do. So youth, where thought
But
we were supposed to be doing?
you just stop. But you just do this to do them separately and stop.
Yeah, man, you're supposed to divide. All right. So the limit as x tends to 1 of x plus 1. So what we're using here now is the ALGEBRAIC, the algebraic approach. Using the algebraic approach. Now, for the algebraic approach, x is tending to 1. For the algebraic approach, I am going to assume that x is equals to 1. Let me ask a question. Is x equal to 1?
No.
What am I doing?
Assuming?
Assuming that it's equals to 1. I am only assuming that it's equals to 1. We went through the intuitive approach just now to know that when we say that the limit is approaching 1, what the limit is doing is getting closer and closer and closer to 1. And then we're going to investigate the behavior of the limit as it gets closer to 1. But in this here case, the algebraic approach case, I am assuming that x is going to be equals to 1. That's my assumption. So in that case, anywhere in the function I see x, I'm going to substitute 1. I'm only doing that because I'm assuming that x is equals to 1. So anywhere in the function I see x, I put 1. So I'm going to have 1 plus 1, which is equals to 2, right? Which is the same 2 as this one here. So we say that the limit approach is 2 from the right and left. So the limit of that function is 2. Now, we clearly see that that method is much easier, very quick and short and fast, right? As opposed to doing an investigation. So when you do the intuitive approach, we are actually investigating the behavior of the function at different points as it gets closer and closer to 2. For the algebraic approach, what we are doing is just assuming we're not going to try and get any closer and closer and closer. We can't bother with getting closer and closer and closer and closer. So what we're doing, we're just going to assume that x is equals to the limit. And in this case, x is equals to 1. And then we're going to substitute that 1 into the function. And then that is going to give me the limit of the function. But still remember that the limit of the function is not that number. It is only getting closer and closer. Are you with me so far?
Yes, sir.
So if we were to look at this other example here now, the limit as x tends to 2 of x plus 1 over x minus 1. Because I'm using the algebraic approach, I'm going to let x equals 2. So anywhere in the function, I see x, I put 2. 2 plus 1 is equals to 3. 2 minus 1 is equals to 1. 3 divided by 1 is equals to 3, which is that same 3 there. So by far, the algebraic approach is the easiest method to evaluating the limit. So whenever you go into an exam and they ask you to evaluate the limit, we're always going to be using the algebraic approach. Then, sir, why take the first half of the class and teach us the intuitive approach? Very good question. The intuitive approach has its advantages, and one of the advantages of it is that when I would move to piecewise function must be utilized using the algebraic approach. When you get certain questions, trying to evaluate unknowns, you have to investigate, right? And the other ones too. Not just the unknown ones. The other ones too, you have to investigate to the left and right of the limit, because you're looking at the limit on a piecewise basis. All right. So I'm going to end there. I'm going to stop and ask, are there any questions?
Not so far.
All right. One of the things that I want to do is I just want to big up Shamari again for going on. This is what was intended. This is going to definitely be part of my research. Remember, I told you that I'm going to be conducting a research on the block scheduling. This is definitely going to be part of the of my research, to say that you are able to keep abreast, because people are going through previous recordings, and I mean, this is the way to go. So students of the class, I know some of you will not necessarily be here next week, because you will be moving over to Calculus 2. But those of you who are here, well, all of you, if you are going to remain in Calculus 1, there are a number of Calculus 1 recordings. Select any one you want. If you want the latest one, that's fine. Select any one that you want and go through the recordings. For those of you who are really supposed to be doing Calculus 2, but you're just keeping our companies for the next couple of days, I would advise you to start watching the videos on Calculus 2, getting your questions in. You can jot something in the WhatsApp group, just title it as Calculus 2, so that, the ones who are doing Calculus 1 now won't necessarily have to pay attention to that. And I will be more than happy to answer. Or, I prefer it that way, because I don't want just a one person. I want everybody to benefit from the conversation. But if it's a one person doing something, and I feel like you want to ask me a question, shoot it. Send me a WhatsApp, sir. I sent you a message. Oh, that's another housekeeping. Don't just send me a message like that, students. Please. Always get my attention in the WhatsApp group. I know I have a responsibility for all the groups that I'm teaching to go through the WhatsApp for those groups. But based on what my function in the college, I get emails from students that I don't know. And your numbers are not saved to my phone, so I can know that, oh, this is Adrian or Oliver or Chevy or whoever it is. All right? So get my attention. Send me the message, get my attention in the WhatsApp group. Sir, I sent a message, and then I can just click on you, and then it goes directly to that message, and then I can action it. Please and thanks. All right? Have a good one. If there are no other questions of me, I'll end the class now. And thanks for coming out. And I apologize for my internet access tonight. Hopefully it will be better for Friday.
Okay, sir.
All right, take care.
Sir,
Yes, please.
I have a question. When you are doing this,
Go ahead, Charlie.
sir, you hearing me?
I'm hearing you now.
Sorry, I was talking, but I thought I was unmuted. Sir, I'm not understanding what exactly you're saying. For next week, that persons for calculus 1 wouldn't be in the class for calculus 2?
No. So I have some students. There is There is just a slight issue. The papers have been marked long time. There's just a slight issue, just very minuscule that I'm trying to confirm with the CCCJ. They told me they will give me a call by the end of today, just to verify something. Um, um, so what I want to do is I just waiting for CCCJ just to confirm, and once they confirm, I will be able to put through those grades. So what I'm saying to you, there are students who I know will pass the course. So I was saying to you that they will not necessarily be in the calculus one like they are in tonight. They may opt to stay. I don't have a problem, or they may opt to use the time for the calculus class to go through the what do you call it now? Their calculus 2 online. So that's an option. Those of you who will be moving over to calculus 2, it means that they would have passed calculus 1. So
Yeah, the problem is
So,
that it's
sir, so for the calculus 1, it would still be the same time, or the time would change?
no, man, this is the time for calculus 1, and then
Oh,
at the end of the 6 weeks, what is going to happen? We're going to be using the same time for calculus 2.
Okay, sir.
Yeah, man.
Because I kind of got confused.
Okay. All right. So that's it. All right. All the best.